I want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. Hello, good evening and welcome to you all. Great to see so many of you here already. Excellent start. A couple of super chats to read out from the off. Super chat from Judy Bassett. Thank you, Judy, for €7 saying, for some cheese. Thanks, Judy, because it was bad news when we ran out of cheese earlier this week. Never mind. Thank you. And from Dora Nku, super chat for €5 for some painkillers. Do you think I might need them, Dora? We shall see. As an aside, someone mentioned somewhere about the cheese play button, and I realised I hadn't shown you guys for a while, so before we start I'll quickly do that. Here it is, my 1000 subscriber cheese button. There we go. I'm not sure how old that is now, but I think it might have moved. I'm not sure if it's changed position. But still working on my theory of evolution. Maybe one day that will turn into Emmental, who knows. But it doesn't smell. So that's a good sign. It was the summer before last. It got a bit ripe. Anyway, thank you again, so many of you for joining us tonight. Hopefully this will be interesting because you know I did a video a couple of days ago countering Nathan Oakley when he did a short about gas not having any weight or something like that that he produced in backup of Brian. And so I reached out to Brian, and Brian kindly agreed to come on stream tonight. We're going to let him tell us about what his thoughts are, his understanding, and then we'll talk about it. It is not a formal debate, but I'll happily say to him, Brian, you're wrong, if I think he's wrong, but it's not a win-lose debate. It's just a chat. Maybe sometime we can have a formal debate, but that's not tonight. Do have one coming up with another Brian Leakey, on Modern Day Debates on Wednesday 13th at 8 p.m. UK time. Just before I bring Brian in, so there's a little warning for you, Brian. I'm going to grab you out the room in a minute. I just see I've got another super chat, so let me just refresh and pick that up. Super chat from Mr. David Oliver, no less, for £5, saying, Gnome means guarding naturally over Mother Earth. I'm not sure I understand that, David, but I appreciate the thought and I appreciate the super chat. Thank you very kindly, sir. So let's, without further ado, bring in Brian and get him to tell us about himself and his thoughts on gas, pressure, inertia, mass, etc. So let's try. Hello, Brian. How are you? Yeah, not so bad, thank you. Welcome to the channel. It's your first visit, I think. I'm just adjusting the sound to get it right. It's your first visit, isn't it? Actually, is that... Oh, hold on. I didn't have the sound switched on. I do beg your pardon. Hello, Brian.
Hey, how are things?
Yeah, it's fine, thank you, sir. I am really grateful that you agreed just to come on and just have a chat. As I just said to her, no, Elon Musk said, so is this a debate about mass? So it's a mass debate. No, it's just a friendly chat, isn't it, Brian? I don't know him that well. So
yeah, it's more like a hashing out of things, really, than that.
Yeah.
I don't know if you could make a debate out of it. Anyway, if you wanted, I don't know. But the reason I'm here is, like, you asked me to come on, so I said come on and try and clear up. I'm getting a lot of comments on my videos,
I bet.
and from people who are misunderstanding what I'm talking about a little bit.
Well, this is a chance then for you to clarify. If there's misunderstandings of what you're saying, hopefully we will no longer misunderstand. Take it away. So tell us what this is basically about then. I'll give you the floor to give us a bit of a chat about it.
Just to get started, I can stay till about 10:10, so it's about an hour.
Okay,
or
so we'll move on. Okay, go on then. So, basically, there's three things: mass, inertia, and weight.
Yeah, well, it comes from. I'm going to start at the very start, right? Gas, right? The description that entropy gives us is that gas will always try and fill a void, right? That's the basics of high pressure to low. It will always try and fill a void. Gas is a collection of very, very small, independently moving parts. That's the difference between liquid and solid. Those hydrogen bonds are broken, so the gas molecules. I'm going to use molecules because some gases will be just an atom.
That's fine. That's fine.
Yeah,
We know what you mean. We're not going to bicker over that. We're not going to bicker over who killed who. Carry on.
Yeah, because H2O is a molecule, but I think like a helium is an atom, this kind of thing, because it's a noble. But there is, I just don't want to be bogged down with splitting hairs over.
No, and I'm not going to. I'm not going to over that. Okay, and I'm quite happy if we use the term atmosphere. I'm not going to say ha ha ha. You've admitted the globe. Okay. We're just talking.
No, that's fine. Yeah.
Okay.
I mean, sometimes I'll use that word. Sometimes it's just after using it for 30-something years.
Okay.
That's just and it's a word you use all the time. So,
well, I mean, basically, I don't think anyone disagrees that gas will try and equalise its pressure into a new area.
Yeah, well, that's how it's described, as it will fill every void it can find, and gas as it's unbonded. It because it's an unbonded molecules, what they'll do is they'll continually move around trying to fill every void. That's what they'll do. So that's why they are constantly moving. When you heat gas, it expands, right? So you're expanding those molecules apart. So the heat also adds in kinetic energy to the gas, so it gives it more energy to move about. So that's why it appears that the pressure rises. When you cool it down,
one second. When you expand it into a greater volume, the pressure will actually drop, not rise.
Yeah, but I'm talking about heat.
Okay. Heat within a given volume.
Only in the same volume.
Okay.
Heat.
Yep.
What happens is that, it will cause the pressure to rise.
Yes, it will,
because it will cause the gas molecules to want to pull apart. And so it adds the heat adds kinetic energy to the gas. So it's like the kinetic energy a gas has is always in direct relationship to the temperature it's at. The temperature kind of decides how much kinetic energy the gas has. Because if the gas still had a load of kinetic energy, it wouldn't be able to phase change back to a liquid. So what happens is as a gas cools down, right? The colder temperatures take away its kinetic energy. So what happens is the gas molecules then are less distance apart. They have less movement to fill all those voids. So if you can imagine, every little gas molecule is moving around in every direction possible, filling every void it can find. And every time it moves, it creates another void. So one moves to one place, it creates a void behind it and has to be filled by something else. So there's no particular vector to gas, if you understand what I mean. It doesn't have.
Well, if you're in if you're in a zero gravity situation, there would be no particular vector. If you had a container of gas here, not under any particular pressure, but a container with some gas molecules in, they are subject to gravity. They will be flying around, but they will be subject to gravity.
Yeah, but when you say gravity, you're speaking about a force, a downward attracting force towards a surface.
Well, you could describe it as that, or you could describe it as a curvature in space-time. Either will do. In effect, it is the same as a force.
No, it's not. If you want to speak about the Albert Einstein's theory of general relativity, then you're not speaking about a force of attraction between masses.
You're talking about something, though, that will impart a vector and an acceleration. But actually, Brian, can we get more, if you can, onto the fact that I think you were saying, because I had a quick glance at some of your videos, something about, you said stuff about inertia. I think you were saying that gas had no mass, or it has mass but no weight, something like that.
Well, see, it comes back to okay, I'm going to give the rundown on mass.
Go now.
There's three different, basically, definitions of mass. There's the older definition, which is an accumulation of matter, right? Now, where that comes from, just give me a moment to go through these because I'll have to explain them. Where that comes from, that originally comes from the Latin word missa, right? Which was used by Newton in his Principia Mathematica, right? Missa means there's a couple of different definitions of missa also in Latin, because like in a lot of languages, they'll use the same word to describe different things. But missa, one of the definitions of missa, one of the main definitions, are the most basic ones, is an accumulation of stuff or accumulation of
Yep,
something.
yep,
Right?
stuff. Mass is stuff. Yep.
So mass, right? So the older definition of mass, which relates to gravity as a force of attraction between masses, is it's an accumulation of matter, right? But after Einstein, that definition changed. It was after that point that physics started defining it as a quantitative measure of inertia, right?
Yes.
And then there's a third one, right? And that is mole, right? Because mole is mass also. Because like 1 mole of something is also mass, if you want to see it that way. One
It's a
mole is
quantity.
yeah, it's a calculated amount of mass. If you're talking about chemistry and whatever, they talk about moles, right?
Okay.
So,
Well,
there are three different. 1 second. There are three different definitions. The first one is an older definition that comes from gravity as believed to be a force of attraction between masses. The second one is that mass is a quantitative measure of inertia. That came after Einstein's time, when Einstein changed gravity from being a force of attraction between masses to an apparent effect of acceleration caused by the curvature of space-time. Right. And that's kind of a circular thing as well, because mass.
yeah, but Brian,
Causes the curvature of space-time.
there's several technical descriptions of mass, but if we take an object in the middle of interstellar space, it has mass.
Well,
However you define it, it has mass. So that's a quantity of stuff with a certain amount of inertia, isn't it?
I'm dealing with mass in the world we're in now, right? I can't deal with interstellar space.
Well,
as that's
okay,
not somewhere I can go,
okay.
right?
Perhaps if we skip on. Well, the only reason I'm saying that is
I don't
absence of
want to
gravity,
skip
so
on
there's
the-
no weight. Okay, all I'm saying is
Yeah.
if you have an object
Once-
that's
I
not.
don't want to skip on. I want to stick on this. This is important. So this is what you have me on, right? So the problem is there's a mix-up between the definitions of mass. So the main problem is that gas is being claimed to have weight, right? It's also been claimed to be mass, right? To have mass. Right?
Yes, gas has mass. Gas has weight. That would be my
This is the
contention.
claim. This is the claim, right? This is the claim, right? But if gas is mass, then mass can't have inertia, because gas does not resist acceleration. Gas is constantly accelerating, as I explained earlier.
Gas does
But
have inertia.
If mass has inertia, then gas can't be described as mass.
Hold on.
And
Hold on.
gas
Say that again.
can't have weight,
Right.
because all of weight is when you weigh something. If you stand on a weighing scales, you're weighing yourself within the medium of air.
Right. I think we need
So how
to.
can air
Right.
have weight within air?
Let's just go back a bit, Brian. Every single thing in this universe, apart from photons, have mass. Would you agree?
Well, I no, because I haven't been like I can't agree that everything has mass. This
Why?
is the problem. I can't agree that gas has mass if the claim of mass is that it is that it has inertia, and inertia is a resistance to acceleration.
Okay. I was
Gas
going to say
does
describe
not
it.
have resistance to acceleration.
Right. If I lobbed a brick at you, I won't, Brian. But if I lobbed a brick at you, it would hurt because it's mass, but it's mass with inertia. If it didn't have inertia, as it hit your chin, the smallest bit of stubble would stop it dead. If the brick did not have inertia, because there's nothing to resist, so it would stop dead. So that brick has mass, it has inertia. So what about a small rock? That would hurt because it has mass, it has inertia. You get smaller and smaller, you might feel it less, but it's still got mass. It's still got. Sorry, I just finished my point. It's still got mass, still got inertia. I lobbed a sand grain at you. Maybe you could just barely feel it. Certainly, if it got in your eye. It's got a very, very tiny amount of mass and a very tiny amount of inertia, but both are there. So with a molecule of air, of gas, it's exactly the same. It's just so small you won't feel it, but it's there. It has infinitesimally small amount of mass and infinitesimally small amount of inertia, you would, potentially you could register it. In fact, you have to be able to register it, otherwise you wouldn't be able to measure gas pressure. And in fact, if I stuck a fan in front of you, blowing in your face, you'd feel it, because those air molecules hitting you have inertia and mass.
Okay. Define inertia.
Inertia? All mass has inertia. Inertia is, every object at rest stays at rest. Every object in motion tends to stay in motion unless acted on by an unbalanced force. So that mass, when it's moving, has inertia. It wants to keep on moving.
That's not the definition of inertia.
Yeah.
It's
the resistance to the... Sorry, say again.
A resistance to acceleration.
Yes, because acceleration is positive and negative. Yeah, so speeding it up, slowing it down. Absolutely. When I go to throw that brick, it takes an effort to throw the brick, and it takes an effort for your chin to stop it.
This is the problem. You see, this is the crux of it. You see, you just stated a few minutes ago that all mass has inertia. Then gas can't have mass.
Why?
Gas does not. Gas is inertia. Gas can't have mass because inertia is defined as a resistance to acceleration.
Yeah.
Gas is constantly accelerating. It never exhibits a resistance to acceleration. It doesn't exhibit that.
Right. So
in its behavior.
Actually, I think I see what you're getting at, because if I had this room, there is air in this room, all the molecules are moving all the time because there's temperature, isn't it?
Yep.
So you're saying, sorry, say that bit again about the inertia. You said gas.
Yeah, because gas is not
doesn't resist inertia.
Gas is. This is why my original, what I was saying to you at the start about what gas molecules do. They're constantly trying to fill every little void, and every time one of them moves, it creates another void. So they're constantly trying to fill every little void, every little vacuumed area they're trying to fill. That's what gas does, because they're unbonded. They're not like liquid and solids where they're bonded together. They're unbonded. So they're constantly trying to fill every little void that's created.
But they absolutely must have mass and inertia. If I put a little scoop of talcum powder on my desk and blew it, it would billow out in a cloud. The reason it billows out is those air molecules have hit the particles of talcum powder and knocked them, sent them flying. Okay. So there must be mass, otherwise it couldn't do that. They must have inertia, otherwise the air particles would stop dead and perhaps bounce off, but they certainly wouldn't be able to move the particles of talcum powder.
Okay, so the force behind the blowing of the air was you blowing, right?
Yes.
The inertia in that example, the only thing that has inertia is the talcum powder. You blowing is the acceleration. So the talcum powder is like the amount of weight that talcum powder has defines the amount of inertia it has.
Yes. So the amount of energy that will be required to get it to move.
Would you agree that inertia requires weight?
No. No. Inertia requires mass.
Well, does mass have weight?
It depends.
Well, inertia, like if you were saying that, if you like, would you? So are you? I need to kind of know. Are you saying that inertia, you can have inertia without weight? Would you say that?
Yes.
Well, how could you resist acceleration if you have no weight?
How could you resist? No, it's got mass. But
mass doesn't mean anything if without weight you don't like. Without weight, you can't resist an acceleration. If you were walking in a wind, and the wind is blowing towards you, the only thing that keeps you from blowing away is your weight.
No, it's your inertia. That might be complicating it a bit. But you have a kilogram of mass, right? Forget the Earth. There's no gravity or whatever, okay? We just take that away. No gravity, suckity, downity, relative density, nothing, okay? You have a kilogram weight just hanging around. That has a kilogram mass. Sorry, I said weight. That's me misspeaking. You have a kilogram mass. That has inertia. If I try to shove it, I've got to shove it with enough force to overcome that inertia, overcome that wish of that kilogram to sit there to actually get it moving. Then if I ran to the other end of the distance, so kilograms coming towards me. To stop it, I will have to apply force to overcome the inertia of that moving kilogram. There is no weight because we're not in a gravitational field.
Okay, let's just say right then, I knew this was going to go this way. So let's say you take a bar, right, a metal bar in a gym, a bodybuilder or whatever.
Oh, okay.
And they put, let's just say, 100 kilograms on one side and 100 kilograms on the other side of the bar.
Yep.
And then they bench press it whatever amount of times.
Yep.
And then they take all them off and they put the exact same calculated amount on in pounds. Right. And let's say the first time they did 15 presses of it, and the second time when they changed it from kilograms to pounds, they did 15 presses. So how many times did they press up weight?
So, well, 30 times you bench pressed however many kilograms stroke pounds. They're just different units for the same thing of weight. And the reason it's that weight is it's an amount of mass in the gravitational field of Earth, 9.8 meters per second downward acceleration. That gives you the weight. So 30 times I have bench pressed it.
Yeah, but you see, the thing about it is this, right? So I know the paradigm we're working off of is a mass attracting mass, which gives things a weight. So mass is given a weight due to a force of gravity. Yes, that's what you're stating.
Well, the definition of weight is mass times gravitational acceleration.
Yeah, mass times gravitational acceleration. Yeah, that's the definition of weight. Right. So a mass is given its weight by a force of gravity having an attraction between that mass and the mass of the Earth.
Well, almost. You could say, given its weight by the gravitational attraction of mass attracts mass, or you could say it's given its weight by the acceleration due to the curvature of space-time. Those are two potential. I mean, they're pretty good. But two potential descriptions of it. The point is, when you take a mass and it is accelerated like that, it's given weight.
No, you can't say the second. Like what you're speaking about there can only be spoken about in gravity as a force, not as Einstein defines it. Because he doesn't define. He never defined weight in his theory of general relativity. In his theory of general relativity, gravity is but an effect of acceleration. So he doesn't define it, and he defines it. He explained it as the Earth coming up to meet the object, and the object being in a position of free fall, right? But the Earth came up to meet the object, not the object accelerated down to meet the Earth.
Yeah, but that's a way of describing it, Brian. If you had someone stood at the North Pole, someone stood at the South Pole, assuming a sphere, then if you drop both of them from 10 feet, the Earth can't physically accelerate northwards and southwards at the same time. It's just a way of describing it.
Yeah, but that's why it's the theory of relativity. But he describes it that way, that the Earth is always accelerating up towards the object. He never defined weight within his theory of general relativity. He never defined weight. He took away when he took gravity and took it away from being a force and made it an effect. He took away mass attracting mass.
Actually, so I'm going to ask you
in his field equations, there is no mass attracting mass.
No, but I'm going to stop you there for a second. I don't want to put you on the ropes for this, but you said when he took away gravity. We've seen lots of flat earthers say that Einstein said gravity is not a force, but no one yet that I'm aware of, I'm not going to hold you to this right now, Brian, but no one that I'm aware of has been able to come up with a quote of Einstein basically saying gravity is not a force. Well, he's described it differently. Definitely.
He described it as an effect.
Yeah.
So why would think about it think about what you just asked. Why would I be looking to find out where he said it wasn't a force when he defines it as an effect?
Yes, but a lot of flat earthers. So as I said, I'm not going to hold you to this anyway, Brian. But a lot of flat earthers have said that Einstein said gravity is not a force. But I don't think he actually said that. As you said, he described it as an effect of relativity. The effect, the gravitational effect, it gives us an acceleration. It is the acceleration of 9.8 meters per second on Earth. That effect against the 1 kilogram mass gives it weight.
So where did I'll ask you the same thing then,
Okay.
Right? A lot of globe earthers, right, will state what you just stated, right? But where did Einstein state that gravity was a force of attraction between masses?
So where did Einstein state?
Where did Einstein state that gravity was a force of attraction between masses that gave things weight?
No, Newton said that.
Well, Newton didn't actually say that.
Well, mass attract. Yeah, but are we going to bicker about words? We know that with Newton's equations, it's talking about mass attraction. No, I'm not having a go at you. But we know that Newton basically was describing mass attracting mass. Einstein's describing the effects differently. But the net result is, either way, if you drop an object while you're on Earth, it will accelerate downwards at 9.8 meters per second. So the whole business of this gas hasn't got any mass is... But coming from the flat Earth side of wanting to be able to deny that the atmosphere, the air, is held down by that effect, force, whatever you want to call it. That the atmosphere can't be held down because it hasn't got mass and there's no such thing as gravity, etc.
Well, let's just write us a couple of things, right? I want to talk about what Newton, and I want to talk about the 9.8 M2. The 9.8 M2 is a calculation of acceleration. Now, that's calculated. That's a calculation that's based within a vacuumed environment, and all the objects falling at that rate within a vacuumed environment. It's not calculated within the air that we live in.
As proven on the moon with a hammer and a feather. But carry on. Carry on.
See, there you go. I'd have issues with that.
I know you would, but I threw that in as a funny. Carry on. It's calculated in a vacuum. Okay.
But if you look at the words that Newton used in his Principia Mathematica, he used the word missa, right, which mass is derived from. The word mass is derived from missa. And missa basically talks about an accumulation of stuff. But then he used the word gravitas. But gravitas means heavy or weight, right? So Newton was initially speaking about, I'm not saying he wasn't edging towards mass attracting mass, but I don't know if he was edging towards that either. But he seemed to be talking about how weight is a force, right? How weight is a force or has a force. Because gravitas means heavy or weight, but gravity doesn't mean that. Gravity is a claimed cause of weight. So the word is derived from gravitas, but it doesn't have the same meaning.
Gravity is not caused by weight.
No, but gravity is a claimed cause of weight. That's what I'm saying.
It's caused by weight. So gravity is caused by
weight.
Sorry, are we misspeaking it? Are you saying gravity is caused by weight, or weight is caused by gravity?
No. Wait. The word. I'll say it again. The word gravitas, the original Latin word used by Newton, that only means it's a description of heaviness or weight, right? But the bastardization of that word, which is the word we originally used after that in English as gravity doesn't mean heaviness or weight. Gravity is a claimed cause of weight. So gravity is claimed to cause weight. Whereas when Newton spoke about gravitas, he wasn't spoken about gravitas causing weight. Gravitas is a description of something that's heavy or being heavy or having weight. Gravity is a claimed cause of weight. Gravity as a force is a claimed cause of attraction between masses, and that cause of attraction gives the mass weight. So when you were talking about 1 kg, you're pushing 1 kg and that have an inertia, It has inertia because it has weight.
But it doesn't have any weight.
But it don't have weight. You can put that
if you are away from the gravitational field of the Earth and the Sun and whatever, you could pick up, for want of a better word, any mass you want. It would have inertia, so it would be harder to move a larger mass, but it wouldn't have any weight.
Yeah, but your example is going off out into a place that we have never been and can't go to.
Well, we have. Okay, think of this.
We have to stick with the world we're in.
if
You can appreciate that.
sorry, I missed that. Say again.
I'm saying you can appreciate that your example involves a place that we haven't been to and can't go. So you can
Well,
appreciate that we're better off staying in
we've
the
been
world we're
pretty
in.
close, pretty close, and to all intents and purposes there, with things like probes to Mars and Jupiter. And I'm not going to argue about whether they went or not. But the point is, those probes still had mass. Because they had mass, they had inertia, a resistance to acceleration, which is why it takes fuel to accelerate them. If they did not have inertia, you could give it a little shove and it would have infinite acceleration, because it has no resistance to my shove.
Okay, if I put that 1 kg weight,
Yep.
sorry, 1 kg mass
Yep.
onto a weighing scales,
Yep.
will it have weight?
No. Well, where are you when you weigh it? If you're in your kitchen, if you're in your kitchen,
in reality, I'm
yeah,
just saying
okay,
reality.
okay.
In reality.
If you're in your kitchen, you put a 1 kg mass on the scales, it will show the weight. Yes.
Yeah. So it does have weight.
Because, and only because, it's in the gravitational field of Earth. It has.
Well,
Well, sorry, it would
yeah,
have weight in other locations, but it only has that
that's not
particular.
weight.
It only has that particular weight in the gravitational field of Earth. If you were on the Moon, it would have roughly 1/6 the weight.
Yeah, but look, you keep on going off with your examples off out into places that are part of. Look, I accept that's your belief, but you keep going off into these places that are part of your belief. It's a place that you can't bring me, and you can't go yourself. So we have to stick with the reality we're in. So if I take 1 kilogram of sugar and I put it onto weighing scales, right, in the world we live in, then it will show a weight.
Yes.
Right.
Yes.
Right. If that 1 kg, right, of sugar had no weight, then it wouldn't. Any breeze would blow it anywhere. It
Yes,
wouldn't
that's true.
have any
Yeah.
resistance.
Yep.
So
Yep.
you have to have weight to
Yes.
have inertia.
It does have weight. It
Yeah, but
has
you have
weight.
to have weight to have inertia.
No,
Because
bro.
you can't resist something without
right.
weight. How can you resist a wind? How can
Brian.
How can I put a rock, right? How can I put a rock, right, out on a footpath in a storm, right, and it not blow around the place if it doesn't have any weight?
Right. It has all three. It has mass. Let's take that rock is 1 kilogram of mass. It has a mass of 1 kilogram. It has inertia, and because it's sat on the floor on Earth, it has weight. And the inertia of the air blowing it is not enough to move it. If you had a super strong hurricane, that may have enough inertia to actually move that 1 kilogram.
The hurricane is the acceleration, not the inertia.
The hurricane is a weather system, but it's atmosphere, it's air moving at fantastically high velocities.
Yeah, but
How does a hurricane blow the roofs off buildings if it doesn't have inertia?
because it has physicality and density.
What's
It
density?
doesn't have inertia.
What's
Right?
density?
Density of matter.
Yeah, but how would you define density?
Density is, well, you'd be talking about density as in a calculated cubic foot or meter or whatever.
Yeah.
That kind of thing.
Yeah,
Right?
it's mass
So-
divided by volume.
Well, see, there you go. It's like if you want to say that density is mass, grand, but how do you then define gas as having mass? Because gas does have density.
And are you saying that gas doesn't have mass?
Well, only if mass is weightless. Mass can't have inertia.
Mass can be weightless. Mass can have weight, depending where it is.
Yeah, you're missing the point.
Go on then. Let's try again. Try me again.
Right. When I originally started talking earlier, right? When I started talking about how gas will always try and fill a void, right? All these little tiny, let's say, atoms, molecules, right, particles, whichever people want. There's different reasons for calling them different things. They all are independent of each other. They all
Right.
move about independent of each other,
Yep.
right? If you add heat to them, they move about more. If you cool them down, they move about less, right? Now,
Less
I know different
energetically,
gases, different gases will, and I'm not going into different gases will have a phase change at different temperatures.
Yeah,
blah, blah,
yeah.
blah.
That's fine. We'll keep away from
And in
that.
general, right? Just as a general, right? So they move about in every direction constantly, never stopping, right? As long as gas is in the phase of gas, it will always be moving around. All these little tiny particles will be moving about in every possible vector.
Yeah.
Right?
Okay.
Constantly, right? So they do not exhibit inertia. Inertia is a resistance to that very thing.
No. Inertia isn't a resistance to some. Oh, hold on. Well, depending how I define it, an object an object of mass has inertia, i.e., it will take a resistance to accelerate it or negatively accelerate it.
Well, yeah, but inertia is defined as a resistance to acceleration.
Yeah, but
So
you're getting hung up on the definition. You're getting hung up on the point is you have
definitions are important.
the definitions are important, but you've got two ways of describing the same thing there. If you have a kilogram mass that has inertia, or you could describe it as inertia is the amount of force to move that kilogram mass. It's two sides of the same coin.
Yeah, but I don't mind. See. This is why I brought up the three different definitions of mass, right? Mass originally, right, was defined as, right, an accumulation of matter, right? Now, mass originally was weightless, right? But it was given weight due to a force of gravity, gravity causing an attraction between masses, right? After Einstein came along and redefined, right, gravity, right.
He just described it differently.
He didn't. He talked about a completely different thing.
The effect of gravity is the same with both descriptions. One was saying you could describe it as large, masses attracting masses. Einstein's saying large masses are causing curvatures in space-time, giving an effect which causes accelerations towards each other. It's 6 of one, half a dozen of the other. Sorry?
What way? Okay, you're saying it caused the effect. Can you give me where he defined the effect that he called the gravity?
No, but...
He called gravity effect. What was his definition of this effect?
Sorry, Einstein's?
Yes.
Well, I'm not going to be able to give you word for word, mate. I'm really not, and that's me being honest. But the point is, okay, put it this way, right? When we had just Newton... he would say if you drop an object, it would accelerate at 9.8 meters per second because of mass attracting mass. Now, with Einstein, he's saying that's a curvature in space-time which causes an acceleration of 9.8 meters per second. It's the same result. No matter what the underlying cause and understanding is, it's exactly the same result. Sorry?
No. 9.8 M2 came from Charles Vernon Boys in 1896.
Well, yes, the exact measurements may be.
Same way as Cavendish and them were after Newton's time. Einstein changed the whole game around. Right? Einstein changed the whole game around with a completely different description. Einstein stated that the uneven distribution of mass causes the curvature of space-time, and an effect of that is gravity. And he did state at one point that the effect we will observe is apparent orbits. He didn't state anything about weight. Weight is not part of he never mentions weight. To the best of my knowledge, in his theory of general relativity, there is no mention of weight. There's no mention of more than one mass. In his theory of general relativity, he doesn't define. He never describes any more than one mass. There's no more than one mass in any of his 10 field equations. And it can't even change one of these field equations, supposedly, without changing several others at the same time, because they're all interconnected, from what I'm told. Now, I don't know the calculus, so I can't waffle off his.
Listen, Brian, that's fine with me, because I'm not a mathematician either. So if you keep it simple, are you saying that air does not have weight? Is that one of the things you're saying?
Yes.
Okay,
well, yes.
So I showed on a video my response to Oakley's 1 minute short in support of you. I showed from Action Labs a vacuum chamber, not with gas under pressure. He just put a lid on, so it's the same as out here, 14.7 psi. It was roughly a cubic foot. He connected it to a vacuum pump, sucked out the air. That vacuum chamber then weighed 25 grams less. So why did it weigh less when all you've done is remove the air?
Yeah, no, I totally agree. You can put gas into a container and you can weigh that container. You can weigh a container without gas in it.
Yes.
Then you can add the gas.
Yep.
Or you can weigh it with the gas and then extract the
Absolutely.
gas.
Yep.
And you can define, right, with that gas in there was this extra amount of weight.
So
And
therefore, therefore, it has to be that gas has weight. That's simple, isn't it?
No, and I'll tell you why.
Okay.
Right. You can stand on a weighing scales now, right?
Yep.
Right, and you'll have a weight. You put that weighing scales at the bottom of an 8-foot deep pool.
Yep.
And you get into the pool and stand on that scales, and you'll have a different weight.
I will have right. I can actually get you 100% on this, Brian. You will have a different apparent weight. Yes, it will read less because you're experiencing. Hold on, let me finish, please. You're experiencing a buoyant force. In my video, I weighed an apple. Okay, I then weighed a container of water, zeroed the scales, and added the apple to it. Now that apple, like you're just suggesting, standing on a set of scales, would, if it was a set of scales inside that water, would not read the full 117 grams. But when I weighed the container, plopped the apple in it, it weighed an additional 117 grams. That weight had not disappeared. It was then part of the whole container and water. So it's not gone away. You are not losing weight. It's just being...
No.
Yeah, you just have the apparent feeling of less weight.
Hang on. You're missing the point.
I'm not.
You're missing the point. If you stood on a scales, right, at the bottom of a pool, right, you put it, right, let's just say you just had your breath, whatever, you went into the pool, you stood on the scales, you're going to have a different reading on that scales than you will have when you weigh yourself out the side of the pool.
And do you know why? Do you know why?
Because you're in a different medium.
No, well, you are in a different medium. Yeah, you are in a different medium. But let's say my mass is 100 kilograms. I weigh myself before I go in. It reads 100 kilograms on the scales. I put the scales at the bottom of the swimming pool, stand on it, and let's just say, for the sake of argument, it reads 75. Okay, so my apparent weight, the weight that I feel on my feet, the weight that I'm registering on those scales, is 75. The other 25 are still there. It's just that they are being supported by the water, which is providing a buoyant force. So I've got 100 newtons pushing down, 25 newtons pushing up, leaving a net of 75.
Yeah, I understand that. I'm not arguing that point. I'm not arguing that point at all. That's actually my point. Your weight in different mediums will change because your weight is only apparent and is only your weight is only defined by the medium, right? If you take a helium balloon, you try and put it on a scales in air, you won't be able to weigh it. But if you put it on a scales in a vacuum chamber, you will be able to weigh it. So
bingo. Well, I'll stop you there, Brian. You're absolutely right. In air, you can't because it's too buoyant. Absolutely right. In a vacuum, you can. Therefore, that gas has weight. You've just proved it again, mate.
No.
You just measured that helium balloon. I presume you've measured the weight of the balloon before you put anything in it.
You're trying to get me on a gotcha here.
No, I'm really not. Well, other than the fact that it is a gotcha.
Why aren't you leaving me speak?
No, I will, Brian. I will, but we both got to speak. Go on, you go.
You pop the balloon, right? What will happen in the vacuum chamber?
Sorry, you're asking me?
Yeah.
You
pop the balloon.
When you pop that balloon that had helium in it, that helium will spread amongst the
vacuum chamber.
The volume. Yes.
What will show on the scales then?
What should? Well, I suppose it depends what's around it, but helium is going to be a tough.
Do you have the same weight as you did have with the balloon?
There will be a total weight the same because it's all in the gravitational field of Earth of 1G, giving 9.8 meters per second per second.
Hang on, you won't have the same.
Where's it gone then, Brian?
When you see, you're not allowing me get to the point.
Go on.
Right? You have to leave me get to the point. You're going in the right direction. But what happens is when we're getting there, we end up tailing off, right? If you put that helium balloon in a vacuum, it'll go down and it'll land on the scales. It'll read something.
Yep.
Right. When that balloon busts, right, that helium will fill the chamber. The reading on that scales will not be the same.
Right.
Why will it not be the same?
Because you're not, well, you are measuring what's on those scales, which is next to nothing. But the weight hasn't disappeared. You just need to measure it better.
The physical density hasn't disappeared. The gas didn't disappear, but the difference is there is no singular downward vector. That's the point. Gas doesn't have a singular downward vector.
But then going back,
when you weigh yourself, one second. This is the whole point.
go on, then I'll come back to it.
When you weigh yourself, you have a singular downward vector, and you're weighing yourself within the medium of gas. So when you weigh yourself within the medium of gas, how can you weigh the gas within the medium of gas? You have to put it into a container. That proves it doesn't have inertia, because if you didn't have the container, you wouldn't be able to weigh it. You can't weigh it without the container.
You just need to weigh things in the correct manner. I mean, if you that guy in the video have a look at it, Brian, afterwards. If he had just set those scales on his desk and said, right, I've got a cubic foot of air above it, how's he going to weigh it? He can't, because those scales are weighing in, the entire column of atmosphere that's above it. So he has limited it to a container. The container isn't doing anything other than just keeping that mass in one place. He weighed it, zeroed it out, and then sucked the air out. And then the container weighed less. So therefore, the contents of that container must have been adding to the shown weight on the scales, and he's now removed it.
But the air was like, if you have something in a vacuum chamber with gas around it, right, and you remove the gas, right, it will weigh a little bit more, because the gas is not there, right, giving it a kind of a lift, right.
It wouldn't be much, right? but technically that's right, because there would be a slight buoyant force on it. Yes.
But the thing about it is this, right? How do you weigh water within water? If you're in the medium of water, how do you weigh water within water? Without putting it into weighing a container, putting that water in a container, then weighing the water within that container on the scales into water.
Oh, that's a bit of a tongue twister. I think I get what you're saying.
You can't define the weight of air within when your whole paradigm of paradigm's not the word I'm looking for. While the whole convention of weighing things is within the medium of air. How can you weigh air within the medium of air? Air doesn't have a singular downward vector in air.
But he just did that. You take a tear. So let's say that the volume of this room is 100 cubic meters, and I want to know how much one of those cubic meters weigh. All I need is a container that's 1 cubic meters internally. Put the lid on it, so it's not under pressure. It's the same as any other cubic meter of air in here. So I weigh it. I get a weight. I zero the scales. I set the tear, and then by sucking it out, I know how much that cubic meter of air did weigh.
Yeah, but you had to put it into a container to do it.
Well, okay. Okay. If I said, look, there's a pond over there, I want you to weigh how much a cubic meter of that water, or a cubic foot of that water weighs. You'll have to take it out, and you can't just pile it on. You can't just pile it on the scales. You'll have to put it in a container just to stop it running away. But the weight is the same all the time.
Weigh, this is my point.
Excuse me.
To weigh gas, you have to put it in a container. That the behavior of gas, right, dictates that you have to put it into a container to weigh it, right? So that alone proves that gas does not have inertia. Because if you didn't have that fully contained, the tops, bottom, all the sides, top and bottom, fully contained, you wouldn't contain that gas.
Okay, but Brian, just to
how can you state that gas has weight when weight is defined as a singular downward vector?
Well, then how can you say
downward vector?
Brian, how can you say that water has weight unless you weigh it in a container? Does even sand? If I want to buy a ton of sand off you, and I've got
water does have a singular downward vector.
Well, water moves.
Because it's inside in air, so it falls through air.
So you only need a floor and walls to that container with the water. There's no difference. And for instance,
when you pour it, water laterally spread out.
Yes, it will spread out, and Brian. I need to respond as well. So would solids like sand. Okay, if you've got a small set of scales, unless you have a bowl or a bucket or something, you can't just pour that sand off because it will run off the sides. So you just need a container. So before you fill it with sand, you measure the weight of the container, zero the scales, then put the sand in until you got the weight you want. That's not a biggie.
Right.
What's complicated about that?
But you're missing the point, right?
Well, you keep telling me I am.
Point, right? Liquids and solids go down. Why do they go down? Because they're more dense than the air. Like air doesn't go down. So you weigh liquids and solids on a scale. You might have to contain sand or water in a bucket or in a bowl, right? You might have to do that within, right, the medium of air. You have to do that to weigh them, right, sometimes, right? But they still go down. If you pour that water out, right, it will go laterally spread out across the ground, right? Unless it gets heated up and evaporates. That's a different issue, right?
But you said air doesn't go down. You said air.
Yes, leave me finish.
Yeah, but Brian, if I don't jump in, I can't respond to any of your points.
I didn't get to finish what I was saying.
You keep saying that as well. Go on.
You didn't leave me finish. Air doesn't go down. You weigh things within that medium of air. So how can you claim that air has a downward force of weight when it's air that you're weighing things in? You weigh all the things that do have a downward vector in air.
Okay.
So you can't weigh air in air. You have to contain it in something that does have a downward vector, like a solid container.
Yeah, but right. First of all, you're saying that the container's giving a vector, but leaving that aside, you said air doesn't go down. It depends. Helium doesn't go down unless it's in a vacuum. Xenon's a very heavy gas. That would tend to go down. You think of World War One, they used mustard gas. That would sit in the trenches because it went down. I know that that's not a pure gas, but the thing still holds. That is unbonded. It's not a solid. It's not a liquid. Because our atmosphere is a mix of all sorts of gases, and I do know that air goes down because I sent up Mage weather balloon to a height of 38.75 kilometres, and 99.7% of the atmosphere was below me. Why was it down and not flying around up there?
That's a separate argument. If you want to have that conversation with me. Hang on. Let me finish, right? Because you have to make a couple of different points here. I want to go back to what you said a second ago. But that particular one, I actually made a 1 hour 37-minute presentation.
What about
on why we have a gas pressure gradient, on why we have a gas pressure gradient.
Well,
right? And if you want to watch that, we can then speak about that afterwards.
Okay, that's fine.
At a different time.
I'll ask Brian. I'll ask Brian that you send me a link so I can watch it. Then we could have a discussion about that. That's fine. That's great. So we leave that. Yeah. But my point being, you said gas. Hold on. My point being, you said gas.
Then I'll leave me go back to what you said about xenon and stuff.
Yeah, but as part of the stuff about xenon and stuff.
What you're saying is a heavier gas, which means it has weight.
Yes, but the homogeneous mix of our atmosphere, which is pretty much the same mix from sea level right on up. The point was, the point was, down here we have it at 14.7. Up there we don't. It's down. So if what you were saying, that gas. Brian, you need to let me finish this one, then I will let you respond. Honestly,
I haven't gotten to make my point.
Yeah, but Brian, Brian, you're not letting me respond, mate. You're not letting me respond.
But you're just not to respond to if I haven't said anything yet.
No, well, I haven't had a chance. You had said gas doesn't go down. I'm saying it does.
And you're saying it for the past 7 or 8 minutes.
Well, I'm trying to. It's just a simple point. The point is, you said it doesn't go down because it's going in all directions, and yet there's a lot of it down here and hardly any of it up there. So you'd need to explain why. Okay, go.
But that's in my presentation. It's fully explained, every single bit of it.
But that's because.
My presentation.
Well, I can tell you exactly why.
I'll send you that presentation, and you can look at it, and you can give a response to it, whatever you want.
I will do, but I would conclude then by saying that the reason is those air molecules have mass, they have inertia, they are affected by gravity, they have weight, although very, very tiny amounts of weight, and they can't. Let me finish my conclusion. They can't. The amount of energy that they have got is not enough to achieve escape velocity. Some does about 90 tons a day. Escapes.
Right. listen, you're making a lot of claims now, and I told you already. This is me. This is me third time telling you. I've already done a presentation on this, so watch that whole presentation, and then you can respond to that. But we need to go back to what you said about a more dense gas, right?
Yeah, Xenon,
because that's why I'm in here today, right? A more dense gas, right? The more dense gas, right? Let's just say CO2, right? If you pour out CO2, right, along the ground, right, inside a room, right?
Sorry.
It will.
Sorry, Brian. Say again. Sorry, beg your pardon.
If you pour out CO2 inside a room, right, that CO2, right, that concentrated CO2 has a greater density than the molecule of air, right? Has a greater density, so it will sit lower, right, because of its density. But it's still behaving as gas. So you can put you would still have to contain that in a solid container to weigh it as a whole. If you leave that, let's say you open a back door, let's say you pour it in your kitchen, right?
Yep.
You open the back sliding door, right?
Yep.
What will happen? Entropy will take place, right? Eventually, all that CO2 will just integrate with all the air. The wind will blow in, it'll all just integrate, right?
Yeah.
But as a concentrated amount, it has more density than the air, so it will sit lower. But, right, as a concentrated amount within a contained situation, right? But the thing about it is, it still is a gas. It still doesn't have all that CO2. It's still moving around within itself in all different vectors and directions. It doesn't have a linear downward vector. Something that you need to have a weight. To give something weight, to weigh something, right? We weigh it within the convention is within the medium of air, the medium of gas. To weigh any gas, you have to contain it because it doesn't have inertia. If it had inertia, you wouldn't need to do that.
Hold on. No, absolutely has to have it has to have inertia unless you're saying it doesn't have inertia and it doesn't have mass. Are you saying it doesn't have inertia and it doesn't have mass?
If you are saying that mass has inertia, then gas can't be described as mass.
What? Why? Because you're saying that gas doesn't have inertia.
Yeah.
But then, in which case, do you know what inertia is, Brian? No, I'm not being funny.
Resistance to acceleration.
Yeah, and if I had an object, if this object did not have inertia, and I threw, or someone threw it at me, it would stop dead when it hit me, and I wouldn't feel it because it's not got inertia. Therefore, there is no force for me to overcome. The smallest hair on my skin would stop it dead.
Yeah, but that's because then it wouldn't have weight. If like, this is what I'm saying. Inertia requires weight. Something can't have inertia without having weight. It needs to have weight to have inertia.
No.
You can define mass as inertia. I don't mind.
Yeah.
But then you can't then define gas as having mass. Gas doesn't ever exhibit inertia.
Okay. So if I had a big container just with air in, okay. If I then crunch that down, smaller and smaller, compressed it, at what point will it suddenly have weight? Not the container, the contents, I mean.
Sorry, if you had a big container...
Take a scuba tank. Take a scuba tank, okay? When a scuba tank is pressurised with oxygen, it has quite a bit of weight, okay?
Mm-hmm.
And I guess you might say, well, it's because it's compressed or liquid. So where does that weight go when you release the pressure? Where does the weight go? Because it's the same mass of air.
What do you mean, where does the weight go?
Well,
it can only be... Yeah, but see, you can only give that gas a weight when you have it contained in a concentrated amount within a solid container. You can only give it a weight then. As a gas, it doesn't have weight. You can't weigh air because we weigh everything within the medium of air.
Yeah, but that's a non sequitur.
How can you weigh water within water without putting water into a container to stop it mixing with the other water?
Exactly. I was just going to say that's like your example about weighing a bottle of water in the water. Absolutely. You just need the right method to weigh it. And in that case, the method would be to take that bottle of water out of the water and weigh it. And then you get the weight of the water minus the bottle.
Yeah, but why are you taking it out of the water? And my argument is that to weigh water within water, The only way to do it is to contain a certain amount of water in a container and then weigh the water that's in the container
But what's the problem
in the
with that?
water.
What's the problem with
Right?
that?
Right? The problem is that you can't weigh it without that container. But
So what?
water, yeah. But you right, if you take a container, right, and you don't have a top on it and you try to put gas in it and weigh it, what'll happen? Will you be able to get a calculated weight?
Well, it depends what the gas is. But I
Oh,
mean, well, actually, no, because you're going to get the 14.7 of the surrounding atmosphere. So
you're
you
going,
just have to use common sense.
yeah, but you're
You
going
put
to have
you put a
you're
lid
going
on
to
it.
have to put gas. You're going to have to put you're going to have to contain it, not just at the sides and the bottom, but you're going to have to contain it at the top. Why do you have to contain the gas at the top?
Because it will escape, just like you'd have to
Exactly.
have
Right.
four
It's
walls to a container of water. I tell you what,
it doesn't
Brian.
have an inward vector.
Brian, it's approaching 10 o'clock, and I know that you haven't got much longer. So
Yeah, after 10 past. After 10 past. Yeah,
okay,
I was watching.
but I wonder, and I have enjoyed this, and I think it's been quite polite both ways, hasn't it? I don't think there's been any problems. I'd just like to read some super chats. Some are questions towards you, which you might like to answer. Okay.
Do you want to do that? Yeah, for the next 10 minutes? Yeah, yeah, okay.
Yeah. So we've got. Hold on. Right. David Oliver, super chat, £5, said, Brian, why do flat earthers keep proving the globe? 15 degrees an hour drift. Thanks, Bob. I guess there's no comment from you from that, though, is there?
Well, it's off the topic. It's off topic. If he wants, I'll give him. If he wants, I'll give him an answer. But my answer would be very simple. It's like if the Earth is rotating at 15 degrees an hour, then we would see things not attached to it having an apparent drift of 15 degrees an hour.
Okay, and I'd respond conservation of momentum, Brian. But you're right, that is off topic.
Conservation of momentum, you need to be attached to the rotating object to
perhaps a topic. Perhaps a topic for another day then.
Yeah,
Brian Pop Robson.
Stick with questions on the topic, yeah, because we'll end up.
Well, I'll read them all, but we can just skip past them if you don't feel they're on topic.
I don't mind answering them, but there's no point in confusing them.
Brian Pop Robson, super chatted £5, saying, if you compress a gas, it will become a liquid. Gas and liquids and solids can interchange. You are saying nothing has mass.
No, that's not what I said. Right? Mass is a term. It's a description. Right? Mass is a description. Right? But if you're going to describe something as something, then you can't contradict it by describing something else with the same term. Right? That's my point. Right? So liquids and solids. Right? Liquids and solids. And gases have all different. There are three different states. They have three different behaviors, right? But if you're going to say gas has mass, and then say the mass has inertia, then that's the contradiction, because gas doesn't exhibit inertia. So that would be my answer to him.
Okay, and I would say that like your first definition, mass is basically stuff. And it's just a case of how compact it is and what form it's in, but the mass hasn't gone away. But thanks for that. Hypervirtualist, super chatted $5 US, saying, this flat earther is really good at pretending to be dumb, OMG. Okay.
Well, I'm not going to give much of a response to that.
That's okay, that's fine.
You have to read it out. It's a super chat, you have to read it out.
Yeah. I've got a super chat from Mr. Walter Bislin. Hello, good evening, sir, and I hope you're still watching. For 5 Swiss francs, mass M1 tells space-time how to bend, and space-time tells mass M2 how to move. So there you have your two masses.
No, that's not. He doesn't understand the theory of general relativity. No.
You do know Walter Bislin is, though, don't you? You do know who Walter Bislin is,
do you? Walter Bislin is. No, he doesn't know what he's talking about.
Okay.
No, M1 is the same mass. He doesn't understand. The thing about it is, mass, right, bends space-time, right, curves space-time. But then that curved space-time, right, in Einstein's theory of general relativity, there isn't a second mass. That same mass moves along a geodesic. It's the curved space-time that causes it to move along the geodesic. I'm not going to go into all the details of it, but he's talking about two masses when Einstein was talking about the same mass. When he says that, when he didn't actually say that, it was someone else that stated that mass curves space-time and space-time moves mass. That's basically the basics of what he just said. It's the same mass that's being spoken about,
okay.
not two different masses.
Okay. Roy Lou super chatted, super stickered €2, and I think it's a hands on ears monkey emoji. David Oliver, thank you for that. David Oliver, super chat, £5. Brian, why does a helium balloon travel faster upwards when underwater when the water is denser than the air?
Because it can't, for a very good reason. It's because of density. Because the helium, right, inside the balloon, right, the concentrated amount of helium inside the balloon, right, can't even handle the density of air. So the density of water is far more dense than the helium can support. So it's about structural support. It's like all more dense matter will displace all less dense matter. That's why in a density tower, the most dense is at the bottom, and the second most dense is above that. The third most dense is above that, right up to the least dense is at the top. So it can't structurally support. So it's like the water basically is putting too much pressure onto the helium. The helium just can't handle the water's density, and so it displaces it faster than the air will.
Okay, that's cool.
Whereas
I get what you're saying.
in a vacuum, there's nothing to displace it, so it comes down to it.
Okay, that's cool. The Snark super chatted €2 saying Mr. Sensible is right and Brian is wrong. Well, thank you, Snark. I'm sure Brian would disagree. Popcorn 2000 Popcorn 2008 super chatted $4.99 saying Mr. Sensible has amazing patience. Thank you. He isn't even letting you respond at all the past 10 minutes. Keep up the good work, Mr. S. Thank you, Popcorn. Mr. Walter Bislin again super chatted another £5 saying Brian, making a presentation based on nothing than your opinion does not falsify known physics, which is applied in practice every day.
Well, he's probably referring to my presentation on the gas pressure gradient. Well, I know for definite he has never watched it, which shows how ignorant he is. If he watched it, he would realize that I use official sources as part of what I'm talking about. So what he's talking about there is absolute nonsense. It only shows his ignorance and lack of research.
Okay. The Elmigs, new name, thank you Elmigs, welcome. Elmigs super chatted €5 saying he's not the Messiah, he's a very naughty boy. I'm sure you've heard that before, Brian. Only the true Messiah would deny his divinity. Right. Oxidator super chatted £5 We've got a lot of Swiss in tonight. £5 saying, wave a large piece of cardboard and you can feel the inertia through the resistance of the cardboard against the mass called air. That's actually quite a good example.
No, that's yeah. I've heard that. I've had that already in comments. So, what is the inertia and what is the acceleration? The inertia, right, is you waving the cardboard through the air. The air is the acceleration because the air is always accelerating. Gas is always accelerating in every vector possible. It's constantly doing that. As a gas, that's why I brought up when I originally came in earlier. I started speaking about the behavior of gas. Gas is constantly accelerating at all the times. So when you're waving that cardboard through the air, it's you is the inertia that's resisting the acceleration of the gas. Right? The gas has density, yes, so you're going through a density, but you are resisting the acceleration. That gas is not resisting anything. That gas is you are going against the acceleration.
Okay. The last one I got here, and then I'll do a refresh. But I think I refreshed not long ago, so I think it's probably it. Mr. E-Man super chatted $5 Australian, upside down dollars, saying, "Why do flags flap in the wind if the air has no mass?"
Well, the wind is an acceleration. The wind is causing movement. It's constantly moving in every direction. Gas. See, I never said gas doesn't have physicality or density. I'm saying it doesn't have inertia and it doesn't have weight. So my point is that if gas is not displaying any inertia, right, then and you want to call it mass, then you can't state that mass has inertia, because gas is not exhibiting inertia, and inertia requires weight, and gas doesn't have any downward vector, singular downward vector that you can weigh it with. You have to contain it to weigh it.
That sort of comes back to something I was trying to say earlier, Brian. Chucking a brick at you or whatever, if it hits you, you feel it because the mass has inertia. You feel wind in your face because the mass of the particles, for want of a better word, of wind are hitting your face, and they have inertia. If they were inertialess, you would not feel it. But I guess we're going to disagree.
Well, inertia is but inertia is a resistance to acceleration.
Yeah,
you're resisting the acceleration of the wind.
Yes. So I'm resisting.
When you pick up a brick and throw it, you're throwing a weight. You're throwing. Then I am resisting the acceleration of the weight. Right. So you're throwing a weight, which is gaining momentum.
Well, I'm throwing a mass, which has got weight.
Well, a brick has weight.
Yeah. Yes, it does, because it has mass and inertia.
Right. It has weight, is made of stuff, and it has weight made of stuff, and it falls through. If it go, it falls to the ground. So it has a linear downward vector, so it can be weighed, right? In the convention of weighing things within the medium of air. So if you throw a brick at me, right, I then resist the acceleration that you have given to the brick by throwing it. And when a brick hits me, it hurts me because it has weight.
And inertia, yes, and that your face has had to overcome that or the.
But the brick is not accelerating itself.
No. I've given it I overcame the inertia from moving it from a standstill to 10 miles an hour flying through the air. Your face stopped it, and you had to resist the force of that brick with your face. You've overcome the inertia, and it hurt.
When it comes to wind, you don't have to pick up the wind and throw it at me.
But I could switch on a wind tunnel, which could blow you over, and if there's no mass and no inertia, you wouldn't be able to do that.
But you're then manipulating the wind. But the point is, you can still have a wind hit your face because the wind is constantly is air. It's a gas. Gas is constantly moving, and because of temperatures, you end up at high and low pressures, which causes movement, right? So wind, which will cause wind, so wind hits your face. Right, that is the acceleration of the wind, and you are the inertia. It is accelerating.
You are resisting the force as it hits your. You are resisting the mass, overcoming its inertia.
You're resisting the acceleration at that point.
Okay. Well, I'll tell you what I'm going to do. Right this second, I'm going to hit refresh on the super chats. And read the last couple to Brian. So any others?
I have to go.
Exactly. So any others will have to. I'll read, of course, but that will be it. And we got 3 more, Brian. Okay. So we got Sofa King Sleepy for $5 US says bat around a golf ball at 45 G versus a bowling ball at 6.8 kilograms. That's mass. It takes the same force to move it on the Earth as in space. Just saying, smiley face, thumbs up. Yeah, so basically, I would agree with that, though, Brian. If I was on the space station, which you may deny exists, but if I'm on a space station and there's 100 kilogram mass, I will be able to pick it up. But I won't just be able to swing it around my head willy-nilly because it's got inertia. I have to pick it up and give it a shove because I have to overcome that inertia. And then to stop it, I'll have to overcome the inertia of 100 kilogram mass moving. But it has no weight.
Let me ask you this. Right, in the paradigm of mass attracting mass and people being on the moon, right, will a hammer, right, have the same inertia as it will on Earth?
Yes.
How will it? Because it'll have only one.
Because it has the same mass. It has the same mass.
But it doesn't matter. It does. But if you take away all its weight, take away all gravitational, right, all force of gravity from that hammer,
which is what I was doing earlier on with examples. But I'm in the middle of nowhere.
Away from the hammer. Yeah. How can it resist movement?
Because it's got mass and inertia. It just doesn't weigh anything.
Yeah, but if it doesn't have weight, how can it resist acceleration?
That's inertia. That's inertia. That's another property. So you've got the mass of a hammer. Let's say it's a 1 kilogram hammer. When I thrust it down, apart from the fact I'll be thrust backwards, we'll ignore that. If I thrust it down, I have to overcome that 1 kilogram inertia. It will hit whatever I'm hitting with 1 kilogram. With 1 kilogram's worth of inertia, would have to. You need 1 kilogram force, if you like, to stop it dead. Basically,
Yeah,
it
but
has the
weight
mass. The
isn't
mass
what-
never ever changes
yeah.
because there's the same amount of stuff in the hammer.
Weight-
Therefore, its inertia is always exactly the same. The only thing that can change is its weight
But
because it's
it
different
can't be, because
depending on the
how
gravitational
does it
environment
resist
you're in.
anything? A foam hammer will have less inertia than a steel hammer
Yes.
because it has less weight.
No, because it's got less mass.
There's less weight. I mean, the whole point is that it will. If you take a steel hammer and you bring it to the moon, right, in the paradigm of
Yep.
of force of attraction, mass attracting mass, then that steel hammer has less weight, so it'll have
Yep.
less inertia.
No.
It'll have less resistance to acceleration.
No,
It'll
it's
be easier
got
to pick
it's,
up.
the inertia. Okay,
What would be
I'll
easier to
state
pick
my
up,
point.
the hammer on Earth or the hammer on the moon?
Sorry, say again.
What would be easier to pick up, the hammer on the Earth or the hammer on the moon?
They'll have the same
Give you
inertia,
less
but
resistance.
they'll have the same inertia, but the hammer on the moon will definitely be less of a stress because I'm not having to support so much weight.
Yeah, but it's not resisting as much. That's the point. Inertia requires weight.
Inertia is only what is the force required to change it from a state of rest to moving, or from moving to a different speed, velocity, or pushing it back to rest.
Okay, well, but see, this is the point. It can't resist an acceleration if it doesn't have any weight. Weightlessness is no resistance to anything.
No, not true. Not true.
We'll have to finish on that one.
We will. So the very last super chat, Brian, was from John Rapp. And it's not a question. It's for $2 Australian. It says, "Oh, Brian, all mass has inertia." Okay.
Okay, he can believe that if you want.
Look, Brian, I'll tell you what. It has been a pleasure. It has been a pleasure. Obviously, we've pretty much disagreed about everything, but that's cool. I have no problem.
Well, I
with
didn't
it.
expect we would agree,
No.
but I wanted to have the conversation.
Yeah.
Anyway, so that was good. What I'll do is I'll send you the video in the next.
Yeah, please do.
Later on.
Just email me the link or something, and I'll have a look. Okay.
Yeah. Yeah, it's about an hour and 37 minutes.
And was this the one about? Was this about Mage? Was it?
No, this is the gas pressure gradient.
Okay. Well, I mean that's quite a watch. That's quite a watch, but I will endeavour to have a good look at it. All right.
Well, what I say to you is it starts off very simplistic, and it's simplistic up to about just after halfway, and it gets a little bit more complicated after that.
That's fine. Not a problem.
And so all I say to you is you'll have to kind of watch through it. I use a lot of official sources, so it's not a case of I'm just making up stuff as I go.
And what I just thought is I have actually put a link to your channel, of course, in the description. But what I'm also going to do... I'm sorry?
I get trolled later.
Possibly. But I'm going to drop it in the comments as well, because I think it's only fair. You know, you've been a visitor, and a good one at that, Brian. There's been no issues, have there?
Okay. Thank you.
All right, lovely. Okay. Thank you very much, sir. You have a good night.
How do I stop this?
Right. What I'll do is I'll drop you in the waiting room, and Colon can explain. All right. Cheers, pal.
I just don't use it much.
Okay.
See you
Thank you.
later. Take care. Thank you. Bye.
Thank you. And what I'm going to do is I'm going to bring in Farmer's Boy and the Snark. I'll give you 30 seconds warning. That was good. I enjoyed that. Yes, I disagreed with an awful lot of it. There's one or two things we agreed on, but not much. Not much. So let's bring in the Snark and Farmer's Boy. So here we have Farmer's Boy and here we have the Snark. Good evening to you guys.
Oh, hello. Good evening, sir.
How are you?
Oh, yes. Entertained.
Good. And Snark, how are you, sir?
Oh, I had some fun. The side chat was not as polite as you. At least we didn't time anyone out. Rachel was there, and I think everybody was.
Good. Nice. Well, I don't know if you're still there, Rachie50, but good evening to you. And it was nice to see Walter Bislin was there as well. Well, I actually didn't see him in the chat, but obviously got the super chat, so that was a nice surprise. He was
there. Yeah.
So, what do you guys think of that? Look. I know you guys aren't just going to F and Jeff about Brian, but you know. What did you think of it? Please be honest.
Okay. Well, in many cases, this hinges on one central piece of misunderstanding, and it seems to be the case here. He kept saying that gas is constantly accelerating. That is wrong.
No,
It's
that's right. It's
bouncing,
not.
so-
It's not. You're correct. It's not accelerating.
and everything flows from there. As long as he keeps believing that gas is constantly accelerating, he will never learn.
Yeah, it could only be accelerating if you apply more energy to it.
Yeah, but he believes that gas of itself keeps accelerating, and thereby it defies inertia. So that's where it hinges, right? So if you can show that that's wrong, which is really difficult, because I said in the side chat, you have to dumb down so far to reach him, it's unbelievable. So yeah, good luck with that.
Have you ever read a series of books? Oh gosh, what were they? Doc Smith's Lensman series of books.
I have not.
You have not. Okay, because one of the things, it's obviously sci-fi, so you've got to take a lot of it with a pinch of salt. But in there, they invented the inertialess drive. So basically, you had infinite acceleration, and you could accelerate right up to an object at full speed, and you would stop dead because you didn't have inertia.
Yes.
That's
I mean, yeah, it's a great idea for a science fiction book, but it doesn't happen because everything that has mass has inertia. I don't get quite how he can accept that mass in a air in a container has mass, but if there's no container, it doesn't have mass. And he kept saying that it doesn't have inertia. If it doesn't have inertia, you wouldn't feel it because those air particles would stop dead when they hit you.
Exactly.
correct, because the second part of, let's say, his combined hinge was yeah, but you have to have a container for that, so it's not true. And that's also a basic misunderstanding, but that's more on the side of a cop out.
And good evening to Schmoker.
Good evening.
How are you, sir?
Hello.
I'm doing well.
Not seen you for a little while. Welcome back.
And
Hello.
later, and welcome here.
Yeah. So how did you think that went, Schmoker? What did you think of Brian's theory?
Honestly, I can't hold that his stupidity too much. It was too much for me. I'm just out of it.
Okay, not a problem. Not a problem. It's some pretty wacky stuff, in my opinion. Johnny Ragadoo super chatted $5 US. Mass has no weight in the horizontal axis, but has inertia in the horizontal motion. I'm not entirely sure I understand that. I'm not disagreeing with you, Johnny, because I don't really know what you're saying. But basically, all mass has inertia. So if you have a mass, it will take an effort to get it moving, to provide acceleration, and an equal effort to stop it again. That is inertia. And he's right that it used to be considered a property of the mass itself, but you can also consider it just to be a quantity of the force you'd have to apply to stop it. But as I said with that whole thing about gravity attract mass versus gravity being bending and curvature of space-time, it's like two sides of the same coin. It's just two different ways of describing the same thing. And actually, who cares? Is it that car it has an inertia, so I can't, if it's rolling along, it takes me an effort to stop it, or is it just the amount of effort I have to apply to stop it from rolling along? Who cares? It's the same.
Oh, by the way, you read my super chat, but the misspellings in there were deliberate.
I guess they were, Snack, but I'll be honest, I didn't feel that was appropriate for me to read.
But okay, he's away now, and I think that everybody understood it when they read it. So okay, we won't repeat it. But okay. Mine. Well,
Hold on. We got Mitchell from Australia in the chat. Mitchell, honest invitation. Would you like to come in for even just for a few minutes? You are welcome. If you want to, Discord links in the description. Jump into the live waiting room, and we'll pull you on. Okay?
Well, shut up. How's that?
Well, we could talk. You know me, Mitchell. You just seen me. Well, I presume you've seen me with Brian. There was no rudeness or nastiness. Who was it I had on just a couple of nights ago? Flatsoid FE, and we had a nice chat. And actually, Mitch, when we had that debate, there was no nastiness, was there? So if you want to come on, hop on in. It would be good to chat about it. I'd like to get your opinion on it. That'd be interesting, wouldn't it, guys?
Yes, certainly. See what he thinks mass is.
Yes, we'd like to know your views of mass.
So I've got a pretty good idea of what mass is, as we define it anyway.
I define mass. The unit quantity is 1/100th of a Mrs. Sensible. That's 1 unit of mass. I'm not going to live through tomorrow, am I?
Okay.
You don't like life to be too boring, do you?
That's all right. It keeps her on her toes. She has to watch it in case she's insulted, so I get an extra view.
Well played.
Yeah,
well
there you
played.
go, Mitch. Conan's just dropped a link. I'm not trying to catch you out or anything. You're not going to get shouted out, muted and booted and all that sort of thing. You know that I'm not like that. So Mr. Sensible was really, really dense. Thank you, Dora. I really appreciate that.
Well, that's not.
Oh,
Very
right.
nice, is it?
Sophocles K said, Mr. Sensible, the point of that last super chat was that weight has a downwards vector. Yes, but the inertia of a mass will resist movement in every direction. Yes, inertia resists movement in any direction. And weight is the gravitational pull against that mass. Yeah.
Yes.
And I just see another super chat's coming while we're waiting for Mitch, I hope. Unless it's Mitch who's super chatting. Come on, Mitch. Hypervirtualist again. Would you like my views of mass? Lol, for $5. Thank you, Hypervirtualist.
I think it's very easy. We simply should ask Hugh Jarvis. He should know all about it.
Huge arse.
Oh yes. He knows about mass.
So I don't know. Is let's have a quick look at the participants. Let's just see if Mitchell is still here. Yeah, Mitchell, you are still there. Come on. Even if it's just for 5 or 10 minutes. It's not to try and roast you or trick you or anything like that. Just to have a chat for a minute. Okay? I mean, if you can't make it, or, let's be honest, just don't want to, that's fine. Just put a message in there. I'll respect that. But it's an honest and open invite, okay? Yeah, so... I had difficulty with him sort of accepting mass under certain circumstances, but then it seems to disappear. I thought brilliant when he said about the example of standing in a pool on a set of scales, it won't read the full amount. Yeah, but that's exactly what I showed with that apple in water. So if that apple was on that scales, it wouldn't read the full 117 grams. But when you weigh the entire pool, the full 117 grams is still there.
Yes.
It's just that it's part of the pull because some of the water is counteracting your downwards acceleration.
Yeah.
So
exactly.
It's not that you can't weigh it. It's just that you've got to use the right technique to weigh it.
I mean, I just don't get this whole thing of gas doesn't have mass. I mean, air, which is of course a gas, it's a compound of gases. Down here at sea level, I believe the control temperature is 15 degrees Celsius. It has a density of 1.22 kilograms per cubic meter. How do we know that if you can't weigh air? How do we know it's 1.22 kilograms per cubic meter? That's because it has mass. All gases have mass.
Which is the whole point.
Yes.
I got his point about saying, well, how can you weigh some water when you're in water? Well, you just need to use the right technique. You extract some of that water so that it's not amongst water. You can weigh it.
I mean, look, they can weigh astronauts when they're on the ISS. And they're in free fall. They're supposedly weightless.
But now that's quite interesting because I have had a couple of comments in my gases weightless video against Oakley. Some people said, and they're quite, I have no problem with it, saying, actually, I think I disagree. If you're in free fall, you don't have weight. What it is, if you're in free fall, you have no apparent weight.
Correct.
But your weight is still there. You just can't feel it. Because, I mean, if I weigh 100 kilograms and I just jump in the air a couple of feet and come back down, my weight didn't disappear for that 2 seconds. It was still there. I just couldn't feel it.
Yes.
And weight is simply mass times gravitational acceleration. While Nathan Oakley was enjoying his plummet from the Burj Khalifa, he was still in a gravitational environment of 9.8 meters per second. Therefore, as his mass hadn't changed, his weight hadn't. The astronauts, as you just said, farmers, the astronauts still have weight. There is still gravity up there. That's a common misconception. People think there's no gravity. There is gravity. They are in free fall. They are falling because of gravity. They're just missing the Earth.
Yeah, and the thing is that if they do want to check their weight, they can't use a conventional set of scales.
No.
But they can use a very clever device that's got a spring in it. And you know the resistance that the spring has. And you're measuring the resistance against the spring of the astronauts. And that's how they can weigh themselves when they're in orbit, when they are in free fall. Yeah, it's a real misnomer to say that there's no gravity up there, because there's gravity everywhere.
Yeah, you'd have to go a damn... well, I was going to say you'd have to go a damn sight out of the local galactic cluster, I should think, to get away from gravity. And probably there'd still be some there anyway.
Exactly, yeah.
And that's why environment on ISS called microgravity, not 0G, actually.
Yes. Yeah, 0G is everybody sort of uses that, but it's a real misnomer. Yes, there is, of course, no zero gravity. They're under the effects of gravity all the time they're up there.
Well, I see Rachie50 said exactly, they still have weight when falling. People tell me they don't. That's true, Rachie. Then people are mistaken. They do have weight because they're in the gravitational force exerted by Earth. They always have the same mass, whether they're on Earth, in orbit, or drifting in intergalactic space. They still have the same mass. It's only the weight that changes. It's a measure of the amount of force you're being subjected, that mass is being subjected to.
And I think what hasn't helped is that as a society for many years, we've used the same, when we say, oh, that thing weighs 100 kilos. Yep. No, it doesn't. It has a mass of 100 kilos. It doesn't weigh 100 kilograms. But we've just got into the habit of using the same the same words to describe something that's actually quite different.
Yes, it's a shame, really, because it causes no end of confusion. And welcome
Correct.
to Hypervirtualist. Good evening to you.
Good evening. It's been a while.
It has. How are you?
Wonderful. And how are you, sir?
Not too bad at all. Not too bad at all. Maybe you're going to give us your views of mass as per your very kind super chat. But before you do...
I wasn't trying to be rude.
No, not at all. Not at all. But before I do, M2M, a super chat of £5, said, I need to lose some mass and lots of inertia. Keep at it, Matt. Oh, okay then, darling. Sorry, Hypervirtualist. Go. Tell us.
Okay. Who brought up you cannot... mass does not have... or it doesn't have momentum or...
Inertia.
Inertia. Yeah.
Well, he was saying that inertia relies on weight. That's what he said. If it hasn't got weight, it hasn't got inertia. And as he thinks gas doesn't have any weight, it doesn't have inertia.
Okay. So simple question for you. I know you can answer it in 30 seconds and it'll be like, oh, yeah, that's really dumb. Now, has anybody in this room ever had like a compressor or anything where they had to fill up a large line or pipe?
So I've had an air compressor for power, compressor tools and stuff.
I've got a little compressor just over there.
Yeah.
Yeah.
So
got one in my van. Yes.
So when you quickly shut off that valve really quickly, right? The pressure in that container hasn't changed at all, right? But all that pressure is going in one direction, right? So you have this mass going down a tube, and on the other side you have a valve which you close, and that suddenly all that mass comes to a stop, but it doesn't immediately. It hits it and basically creates more pressure than it did when it's stable, right? And you see that needle on your measuring device, and it pops all the way up and then back to where it was. Why do you think it does that?
Yeah, because it's got inertia.
Yes, you get a pulse. You get a pressure pulse in the line.
Yes.
It's a very well-known effect in all sorts of things that have gases moving down, like car exhaust, particularly if it hasn't got a turbo.
I believe
you get
such
pressure
effect
pulses.
I believe such effect have special word for it, but I can't remember it.
It's worse than that because different types of compressors need to be built for different reasons. Like a compressor in a jet engine has to be built to move massive amounts of pressure of air,
There you go,
but it's
mass.
not really pressurizing it into a container. It's just pushing it through a combustion chamber, which adds more pressure and it gains more energy to keep the system working,
Yes.
right?
But I just don't
And it's
know.
relying on the expansion again afterwards.
Yes,
I just
but none of that won't work. I'm sorry, Mr.
no, that's
Sensible.
what I was going to say. I just don't understand. I mean, I'm assuming none of you are physicists that rely on physics or do jobs that rely on esoteric physics or anything like that. We're ordinary guys and gals, okay, with a certain lay level to whatever level of physics. But I wouldn't dream of sort of grabbing Stephen Hawking and telling he was mistaken about all these things, or Neil deGrasse Tyson and saying that he doesn't understand Coriolis. I wouldn't dream of it. My first position would be perhaps I'm misunderstanding it.
And there you go. And Brian says that Walter Bisling is wrong.
I know.
Yeah, right.
Yeah.
Oh,
No,
I like,
Walter Bisling could be wrong. He could make a mistake. Of course he could. But what's the odds of him making a mistake, however slight that is, against you or I?
Well, as I think Neil deGrasse, as science communicator, choose sometimes wrong words.
I think so too. He does have to make it interesting, exciting, and dumb for us masses. But I agree. Sometimes he could. But then he's talking to people who want to learn. He's not trying to make statements that are going to be picked apart by the likes of Nathan flipping Oakley.
Oh, Mr. Sensible, if I could, right? I would like to apologize to you.
Oh, why's that?
A while back, I had a wonderful conversation with you. I think it was wonderful. I think we both enjoyed it. But I was overly critical about the virus going around, and I think I gave bad information.
Well, if you gave bad information, is that just not an error?
Yeah, it was an error. I had bad information at the time, and I
Okay.
think I advanced that bad information very poorly.
Okay, but I mean, we can all make mistakes. I mean, when I've been thinking about this whole thing of do you have weight when you're in free fall, and I had a couple people make comments, I sat there and thought, they gave some examples or whatever or some reason. I'm thinking, I wonder if they're right, and I had to go and double check myself. And had I been, well, I think I'm right, but had I found, oh my goodness, I'm wrong, or if someone now contacts me, explains it, and shows I'm wrong, I will openly admit, look, guys, I was wrong.
Oh, I was wrong.
Yeah, exactly.
I was definitely wrong. Since then, I have got the vaccine. I highly recommend other people get it too. I unfortunately live in Florida where I got very sick even after the vaccine. But luckily, because of the vaccine, I didn't die. And I just want to, thank you for being in the situation you were and putting out good information.
Well, thank you.
But-
I appreciate that.
I will let you go on with your show. I enjoy it and continue on.
Well, thank you, Hyper. But actually, since you've brought up the subject about the vaccines, I want to share something. I'm having to be careful. 2 people I know, turns out that they had concerns over getting vaccinated. They had concerns that they felt it wasn't long-term tested and all that sort of thing. Now, I can only assume that they've got those concerns based on stuff they've read, perhaps on Instagram, Facebook, or maybe YouTube or whatever. They decided not to get vaccinated. They both came down with COVID and both got really quite ill. A neighbour who was a doctor popped in to see them, and one of them, he tested the oxygen level of one of them, and it was just below the level that's considered, right, contact the hospital. So he basically said, you need to get an ambulance. which they, well, surely not, but in the end he persuaded them they'd have to. They did, and she was hospitalised, and after 3 days, she's intubated. It's now been about 5 or 6 days. So it's extremely serious, because once you get to that stage, it's basically a coin toss, a coin toss even. 50-50, will you survive or not, once you get that far?
Yeah.
And I've also recently read that I think it's 50% of people in hospital are unvaccinated, and 90% of those who are intubated are the unvaccinated. Get vaccinated, people, if you haven't.
Yeah. My one of my family members called me a few days ago while I was still going through the COVID, and I guess she hadn't been vaccinated, and my mother wasn't vaccinated, and right now, of a couple days ago, my mother is missing somewhere in Alaska and might have had COVID. So, and that what's really sad about it and really painful is that that person that was telling me this was also refusing to get vaccinated because they didn't feel comfortable with the vaccine. So
Here in France, it is invariably so. If you talk to somebody who is refusing to get vaccinated, the first sentence they utter has something with the government in it. They don't trust the government. The government says get vaccinated. They don't trust the government, so they don't get vaccinated. How illogical is that?
I know. It's sad, isn't it? I mean, I wish I'd known that these two people had that as a concern, because I wouldn't have taken the mickey out of them. I wouldn't have had a go at them. I'd have given them the information, you know.
Even Trump said get vaccinated.
I mean, it's obviously they haven't gone to any sort of official source, because it's not like in the UK, the National Health Service sort of says COVID vaccine. Well, it looks good, but to be honest, it hasn't yet been long-term tested, so there might. It's not. That's not the case. I want to read a super chat from Judy Bassett. Thank you, Judy, for €5. Is there a verb in English that means to measure the mass of something? I was going to say, well, yeah, that's to weigh. No, it's not to weigh it, is it? What's the word for measuring the mass? Is there? I don't know.
I think it is still weighing as well.
It is weighing, is it?
Yeah, I think
Even though there's no weight.
but there's mass.
But what about Brian's inertia?
Well, he got a lot of that. He's impossible to move from the position where he is, which is completely wrong.
He's got a real resistance to a change in velocity, yes.
Yes. It's actually quite difficult at times. I know when you're in a discussion, especially if someone's saying something and you want to counter that point and he wants to counter my point and so on, not talking over each other. But I felt that I would give him the run, but then he said something in particular, and I want to address that. And he wants to carry on. He said, but I haven't finished my point.
I want to make my point.
Yeah. But then the moment I started, I would not get far. Then he disagreed with something. That's fine. But he'd be talking straight over me. So.
Yeah, he did. Yep.
But there was no problems with it. I think he was absolutely fine as a guest. And I'd happily have Brian on again.
I agree.
It's fun.
Although there are always people, but I think it was not many this time, who get bored with the level of stupid, and they simply say, well, okay, this is all I can take. I've seen it again in this stream, but, well, okay, I think it was mild. Because at least it was, well, it was not too much talking over each other. It was still civil.
Yes, it was civil. It was civil. I mean, I felt myself at one point getting frustrated, and so I forced on my point. But, yeah, I have no issues at all with Brian. Only in all the crap he's spouting.
It was civil type of stupidity.
Yeah,
Whereas Wally in the chat says exactly what one of the core points is. Water has mass, but steam doesn't.
Yeah, I just saw that from Where's Wally, yeah.
Yeah.
Yeah. Where does he think it goes? You can't switch it on and off. Well, if you could... If you could, would we basically be inventing anti-gravity?
Buoyancy,
Yeah.
buoyancy just cancelled weight of steam.
Is gravity just negative buoyancy?
It was Raichi who first made me think about how do these clouds get up there and why does it then rain? I mean, why it rains, okay, but how do the clouds get up there? And she made me think about, let's say, atomic weight, molecular weight, and I said, yeah, that's it. So, hey, now I learned something because of, we still had a Discord chat then. I broke that off when things ran a bit wild. But yeah, that was one thing I learned thanks to the Raichi.
Well, Mr. 42, thanks 42, says weight molecules. Duh. Are you sure it's not just downitrons, succitrons, or pullitrons?
Pushitrons.
Well, pushitrons are like anti-pullitrons, aren't they? We really must discuss this with CERN, see if they can get to the bottom of that. That would be interesting.
Do you know what? I've got a funny feeling they might not oblige you.
There will not be a pushover, Ethron.
Oh dear. No such thing as anti-gravity, says just call me Avi. Avi, never mind that crap. Watch out for that spider right behind you, pal. It's creepy. Yeah, it's going to get you.
I mean, you mentioned earlier, what was it? Was it the Lensman series?
Oh yes, E. Doc Smith.
Which I've heard of, but I've never read myself. But you said they had this way of overcoming, being able to accelerate. You know.
Yes. Just before we go into that, what I will say, if anyone's thinking, oh, do you know what, I might read that. It's sort of 1960s sci-fi, so it's very much shiny space rockets and stuff like that. So it's quite dated. But once I've bought a science book or got hold of a science book, I've got those from second-hand shops, I think. If I enjoyed it when I first read it, I'll keep it and I'll read it again and again. So yeah, it's rather dated. But yes, they had inertia. They could make their ships go inert.
Yes, you'll see in a lot of modern sci-fi stuff, and I'm sure they've mentioned it in things like Star Trek. They have this thing that are called inertial dampers. And they are the same sort of mythical thing, because if you watch on Star Trek, when they're sitting on the bridge, it says, right, warp factor 4, and they just go.
Yeah, but
I'm sorry, in real life, if they went that fast, that entire bridge crew would now be red smears on the back wall.
Well, no, not if they're inert as well, because it would you'd have infinite acceleration.
Well, yeah, you have to you have to somehow stop the inertia having an effect on you. I mean. Mm-hmm. Yeah, we've all done it. I'm sure at one point or other, we've all been in a moderately powerful car, and you put your foot down and you get pressed back into your seat, and that's at piddling speeds. You know, going to warp factor plenty, you're going to go splat.
Yeah, but
Alton Towers. No.
In theory, if you could have inertial dampers, basically wiping out inertia, it would be no problem.
Exactly,
but then you may as well make the whole ship inert. In which case, someone fires a missile at you, it explodes, or if it hits you, it won't hurt because you're inertialess. When you get hit, you just move back.
Or that engine just accelerate whole ship and the crew and everything inside it at the same rate. So
sorry, say it again, Schmucker.
That engine just accelerate everything in this ship. Including crew, including air, everything inside it with same acceleration. Yeah. So you don't need that inertia dampers.
And basically, you could not be harmed if you crashed into a small moon. It wouldn't be a crash. You'd head up and you'd stop dead because you've got no inertia. So you're not going to fling forward through the view screen or whatever. You would just stop dead. Shame it's a load of crap, isn't it? It doesn't exist.
The most impressive acceleration I've underwent was in Rita Queen of Speed in Alton Towers. That was cool.
I wouldn't know about that.
No, I don't do that.
I think it's got a different name now, but it's a ride where you're launched horizontally. So you go from 0 to 120 kilometers per hour in record time. So that's a massive, pun intended, acceleration.
Well, an old Land Rover I had, I decided to find out it's 0 to 60 It didn't get to 60. Oh man,
What's the
that
0 to
scream!
60 time? I don't know. We ain't got there yet.
Yeah, we need to go onto a different scale. Pass me the calendar. Oh man. Right.
Maybe
Peter
that should
G
have been 0
says.
to 60 kilometres now.
Peter G says inertial dampeners work because plutoniums say that it works. It's all because of budgetonium. Budgetonium.
Budgetonium. Yes.
Yeah, we've not got much of a budget. That's no moon, says the Elmigs. I got a bad feeling about this.
I think they actually show it of all the sci-fi that tend to do it accurately. I think The Expanse.
I enjoyed that. Yes, that was very good.
I've enjoyed it so much. I've gone back and started watching it all over again.
Yeah, I might watch that again.
But you'll notice that they've only got gravity, as it were. They can only walk without using their special boots when their engines are firing. As soon as they turn the engines off,
you
they
drift.
have to turn their magnetic boots on.
But actually, then they must be under constant acceleration, not just travelling along. They'd have to be accelerating, otherwise they wouldn't be able to walk. And if you're listening, they'd still have the same mass and they'd still have the same weight. They just wouldn't feel it. Yeah, so things like 0G plane is a misnomer.
Yes.
Because it's not in 0G. That's why it'll bloody fall down if they don't pull out of that.
But I think to the average person, when you watch these film of them in the Vomit Comet, it looks like gravity's been switched off.
Absolutely. Just as it looks like that in the ISS.
Exactly. You watch them floating through the various modules, or you watch the astronauts working out. I see the Russians are out there again today. You watch them floating about, and it looks like gravity's got no effect on them, but of course it has.
Yeah.
And yes, you can't. It's difficult to wrap your head around the fact that ISS and the astronauts outside are both moving at ludicrous speed, because that shout out because somebody did.
Yep.
But it doesn't look like it. It just looks like they're just hanging in nothing, and they're not going anywhere. And
hanging in the air, just like bricks don't. But it's no different than two cars driving alongside each other at the same speed. Because I've heard people like Level of Observer talk about, how can they catch that satellite if it's travelling at 17,000 miles an hour? Yeah, but so's the ISS. It's just like two cars heading down the motorway side by side. If you got close enough, you could pass an apple from one window to another. That's not a problem.
How do you think aircraft refuel in mid-flight?
Yes, exactly.
Because they both fly at the same speed.
Actually, that's a nice example. I must remember that. And next time I come across someone spouting that sort of derp. Yeah.
It's a careful manoeuvre to perform, obviously, but both aircraft are flying at the same speed. And it's just a matter of, one holds the position. Obviously, the refueling aircraft basically doesn't do anything.
Yes.
And the guy that wants the fuel comes up behind it and gently manoeuvres into the spot, and and away you go. And they could both be doing, I don't know what sort of speeds they refuel at, but they could be doing 200, 250 knots.
And I think that refueling unit is pendulum.
I'm sorry? Oh, spendulum.
Yeah.
Spendulum.
What's this? Gas constantly accelerating. Yeah, going faster than the speed of light. Yeah, that's right. So, Brian's thing saying it's constantly accelerating. Maybe let's give him the benefit of the doubt. He means it's speeding around, not accelerating. He just means it's constantly travelling. I'm going to give him the benefit of the doubt with that, because I didn't want to be picky over words. I wasn't going to go picky over things like atmosphere. Oh, I'm not going to say atmosphere, or I caught you because you said atmosphere. No, we know what you're talking about. Whether you call it air or atmosphere, that's fine. Yeah, don't want to be arguing about that.
No.
But yeah, it was interesting. But Oakley's sort of got onto it as well. Oh! Good point. Yes, mustn't forget, Mr. Malert. Hopefully I said that right. Super chatted $4.99. Always remember Moonbase Alpha, September the 13th, 1999.
Oh,
absolutely.
Yes.
I love the intro music to that, And I also remember when I was a kid, one thing I never had was one of those models, toy models of one of the Eagles. I loved those.
I don't know whether it was a dinky or it was something similar to that, but it was metal, and it was one of the Eagle spacecraft. And I'm sure you could take off the
cargo, yes.
Yes,
They were
that's
brilliant.
it. Yeah, I had one of them. Oh God, I wish I still had that.
Yeah, it'd be worth paying, especially if it's still in its box.
Oh, you
but-
must be joking. Come
yeah.
on, toys never survive.
But that was such a cool-looking
thing.
spacecraft, wasn't it?
It was, and I think that was that Jerry Anderson's last.
I don't know.
Was no, because he did Terrorhawks after that, didn't he?
What about Sylvia?
Oh, possibly, yeah.
I
But,
don't know. Oh, Dora and
that
Coo
was-
had one of the Eagles. Lucky. Oh, so did second best Bob. Thanks, Bob.
There you go.
And,
Yeah, no,
Dora
mine-
had the
mine
Airfix
wasn't-
one.
Yeah, mine wasn't a kit. It was an actual. It was metal. Most of it was metal.
Yeah, I remember exactly the ones, pal, because I was absolutely desperate to have one.
And it's a good job it was metal, because that had to withstand a fair amount of abuse when I played with it. That made all sorts of crash landings and all sorts of things.
Oh, Mr. Andrew, everyone had one. Was I the only kid who didn't have one? Me and you farmers. Oh, that's fair, isn't it?
Oh dear. I think it's all on YouTube as well. I think it's all still there.
What, all
somewhere.
the Space 1999?
Yeah, I think so.
I recently noticed that Eagle looks like some kind of angry cyber face.
It did. The windows did look like eyes, didn't they?
Yeah, and door looked like mouth.
Oh, so someone said the best thing about Space 1999 was it Barbara Bain.
Oh, yes. She was like the second in command, wasn't she? She, in real life, was married to the leading character, who's was it Walter Koenig, whatever his name was?
Walter Koenig was Mr. Chekhov. Where do they keep the nuclear vessels?
Oh, what's his bloody name? The guy who was in charge, Martin Landau. Martin Landau played the chap who was in charge, and Barbara Bain, I think, was like his second in command. In real life, they were married. They were a married couple.
Right.
When they filmed it. And I only found that out the other week. I didn't know that.
What were you researching then?
I went down some rabbit hole somewhere. I can't think. I think because I'd watched some of it on YouTube and sort of started Googling it, and it's amazing what you can find. Yeah, Martin Landau and Barbara Bain, I'm fairly certain, were a married couple at the time of filming that.
You've done your own
a certain
research.
chemistry.
Sorry,
What was that?
You have done your own research.
Well, this is a problem. They say do your own research, so you go and do your own research.
Well, diecast, as suggested in there, diecast Space 1999 VIP Pod Eagle diecast model product Enterprise Jerry Anderson boxed, £200.
Bloody hell! Yeah, it was a diecast. Yeah, it was a diecast model I'd got. It was metallic.
Oh, it was a 1974 dinky diecast Space 1999 Eagle transporter with pod, £26. But it's actually comparatively small. Seeing it against an adult's hand, I always remembered it being bigger than that. But I guess, there's several others. They're all in. Oh no, I don't know.
I always remember it being a decent size.
Yeah, but you had kids' hands then, didn't you?
Well, yeah. Is that why wagon wheels always seem so much smaller today?
There you go. Dinky Eagle Freighter boxed and original, £159.95.
Cool.
Hell, someone's selling one of the cargo pods for just £40.
I presume that's in sort of mint condition, unlike
boxed.
I've played with this for 5 years.
Yeah, stuck it up my nose.
Well, you can even have a fur coat in a mint condition. Sorry.
Oh.
Bob said it's on again on TV, I presume. Again, now it's not as good as we remember. I know, Bob. I've watched a couple of little bits on YouTube. I didn't realise the entire series was on there, and it dates. But
yeah,
I'm aware of someone who won't watch any films from pre-2000 because they're old and rubbish.
What?
But I know. But if you took it, the thing is, you can't take a date like that because films that are produced now might look stunning, like the Matrix films. But in 20 or 30 years' time, they're going to look quite dated. Star Wars was cutting edge, absolutely cutting edge when it came out. But now you can see how these special effects are quite dodgy.
What was the cut-off date again?
Well, for him, he said 2000.
Right, so he can't watch The Matrix.
Yeah.
That's 1999.
There you go.
And yet at the time, and even now, I mean, I watched that. I have to admit, I watched that again the other night, and I thought, yeah, it's the first one. It's a good one. You have to watch closely for sort of mistakes and gaffes, and there aren't that many. And you watch it now, it's still a bloody good film, and it's 22 years old.
Yeah, yeah.
And
with
at the
Star
time,
Wars, with Star Wars
was cutting edge.
Yeah, but I can remember watching previews of it on Saturday morning kids TV. And they were showing little bits of the when they're escaping from the Death Star and they're fighting the 5 TIE fighters. The computer graphics of the grid that drew up on the screen. Wow, how did they do that? But the actual TIE fighters, now you look at it on a good quality TV or on a projector, you can actually see the transparency overlays where they were laid out. Do you know what I mean? You can actually see it.
Yes.
But that was the best they could do right then. Oh, and Colon says, Alien, 1979. Absolutely.
In those few years, around about that time, you had Alien, you had The Thing.
Oh,
you
yes.
had American Werewolf in London. He won't watch
excellent.
any of them. I mean, The Thing is an absolute classic of practical special effects.
Yeah, practical. That's it. I mean, they don't do that now.
And it stands the test of time. You watch it now, and it's still a bloody amazing film.
Yeah, I don't know how they did some of that.
Hey, madman, that's impossible. You cannot forget Casablanca.
Oh no, we draw the line there. That's old-fashioned rubbish.
Old-fashioned, not rubbish, but okay. In terms of special effects, no.
Clive Wells.
2001: A Space Odyssey.
Clive Wells says, "Who remembers Blake Seven?" Do you know what Blake Seven and Avon is? Why I got into computers, because he was my hero. Avon was. He had ORAC and he had this long sort of tool with like a disc on it, and he was doing computer work. I mean, there was no programming there. Yeah, loved it. Avon and Callie Villa. He was a brilliant character. Gan, Blake. Oh gosh, who have I missed out? Jenna. That's 6 of them. ORAC.
Who was Serverland? Which one was
Serverland? Was the baddie.
That's right. Yes.
Yeah. The Federation.
I think at the time we'd been brought up on Doctor Who, and it was always happy endings and all the rest of it. And then Blake Seven came along, and it was darker. It was grimier. It was, it was probably more real life. It wasn't all sort of bab, happy ending. Thank you very much. Good night. It was just something. It was a much darker sci-fi, and I think when I was a kid, that just appealed somehow, and it was.
But Farmer, I actually quite a few years back got the entire series on VHS, and it had dated quite a bit. There's one bit in the first episode. They've got these double doors. They're ordinary doors with handles, and as they open them, it went. And there's another thing. They ran down this corridor, stopped, and you could see all the bubbles in the wallpaper that slapped up.
I know. I mean, you go back and watch the original Prisoner Cell Block H, and the walls wobble.
Yeah.
All of the programs of that age, that no money was spent on the sets. Yeah, they didn't have huge budgets, and I know you watch some of it now, and it just makes you cringe. But at the time. When I was a kid, when Blake Seven came out, I mean, I loved it. That was must watch this,
Second best, Bob says the Liberator spaceship. That could have been one of the 7, but there's also Zen, the computer.
That's
and
right.
Slave, the second computer, wasn't it?
Yeah, I liked the Liberator. It got that sort of 3 bodies.
Yeah.
It was like a triangular sort of cross section, wasn't it? Yeah, that was, yeah.
Second best, Bob also said, I did see the first Star Wars at the cinema. I was amazed. Yeah, the same goes for me.
Yeah.
Let's say in Earth history, not the way it's ordered now, but that was great. Also the music. Right?
No, I missed the first one at the cinema. I saw Empire at the cinema.
The one thing filmmakers still doing wrong at the modern time is turbulence flow in vacuum. which should not be the case. It should be laminar flow always.
Yes, you do see billowing clouds with explosions. No.
Yeah, no. If you see dust and clouds, which
well, actually worse than
turbulence.
That, I think with things like Blake Seven, like the old Flash Gordon, when you see that sort of thing, you've got the clouds of smoke going up and sparks and that going down.
Down, yes.
Anyway, guys, it's been great. I've really enjoyed tonight. So I am. I just realised that what's her name? Hypervirtualist just disappeared, didn't she? Never mind.
Well, she must have just slipped out.
Or slipped out or dropped out, I don't know. But Hypervirtualist,
Yeah,
thank you for
just
joining us if you are still listening or watching it back. Guys, thank you very much. It's just gone 11, so we've been going just over 2 hours. It sounds like a nice place to end it before we wander off into some... we'll try and keep it a little
Because
bit...
we've never done that before.
No. Oh,
Tell me
dear.
about it.
Okay, guys, what I'm going to do is I'll pop into the waiting room where the ever-patient colon is sat. Thanks, C, for your help, as always. And hopefully see you guys again soon, yeah?
Yes, it's been a pleasure.
A pleasure indeed. Thanks very much.
Good night, farmers. And to you, the Snark, good night. And to you, Schmilker, good night to you, sir.
Good night.
Good night. So, I really enjoyed that. I think Brian was a good guest. Yes, we disagreed on everything. Yes, he said a lot of silly, but we were able to talk it through. We could have gone at each other at hammer and tongs, but we'd have got absolutely nowhere. Absolutely nowhere. Hopefully we'll do something like that again soon. But as I said, on 13th September at 8 p.m. UK time, I'm on Modern Day Debates with Brian Leakey. It's going to be a bit interesting because we got several topics. We got gas, air pressure, we got eclipses, and we got stars. Stars is a bit of a vague topic, so I'm not exactly sure where he's going with that. But it'll be interesting. So I hope you'll join me there. Although what I will do, I think it's okay to, is after a few days I'll mirror it onto my channel as well. Thank you very much for joining me. I do appreciate you all, every member, every patron, everyone who has super chatted, everyone who's just been and joined in. I hope you've enjoyed it. See you soon, take care and stay sensible.
Mr. Sensible, Mr. Sensible, bring me some cheese, and get me only the best if you please, best if you please. Here are some flowers, let me display them. Name it a one or you have gone or slay them. Mr. Sensible, you are a man. Every subscriber is a faithful fan. Bring your logic and your cheese. Mr. Sensible, help us out, please. Mr. Sensible, I needed proof of gravity, so I jump off the roof. It's hard enough, let me go further. Why was I ever such a darn flat earther, Mr. Sensible? I'm such a clown. I am the laughing stock of the town. Bring your logic and your cheese. Mr. Sensible, help me out, please. Mr. Sensible, bring me a sphere, to which the waters of the oceans adhere, have explanations, but let me be candid.